Arithmetic sequences. So, negative 15, negative 7, 1, 9, next. 17, and 25. Negative 4, negative 7, negative 10, negative 13, negative 16, and negative 19. Note that for each sequence, the difference between any two consecutive terms is the same value. So you always go with the term that's further and subtract from it the previous term, right? So you go 7 minus negative 15, right? It works this way. 1 minus negative 7, 9 minus 8, etc. No. Negative 7 minus negative 4, negative 10 minus negative 7. So a sequence is arithmetic if the difference between consecutive terms is constant. This constant is called the common difference, is denoted by the letter D, and D is equal to T2 minus T1, or T3 minus T2, or T4 minus T3, and ultimately T sub n, any term minus T sub n minus 1, which is just a way of saying a term and the term before that term, right, the previous term. What is the 20th term of each sequence? Well, recursively, which is what we're doing basically, right? We're just doing this recursively. We're looking at it, we're coming up with the rule, which is add 8 or subtract 3. And that's our rule. In order to get the 20th term, then, we would have to keep going until we had 20 terms. So it would be a better idea if we had a formula. And this formula is called the general term. So let's complete the following table for the sequence. Negative 15, negative 7, 1, 9. So we have negative 15 plus 8. Then we add 2 times 8. We add 3 times 8. T10. How many 8s are we going to add? 9 eighths, right? 9 times 8. And T sub n. How many n's are we going to add? N minus 1 times 8, right? We're adding 1 fewer 8 than the term that we're on, right? That way the first term comes out as it is. We don't add anything to it. For the second term, we add 1 8. For the third term, we add another 8 to that, or a total of 2 8s, and so on. Okay, let's look at a general arithmetic sequence. So we've got T1. T2 is T1 plus D. T3 is T1 plus 2D. T4 is T1 plus 3D. What's T10? T1 plus 9D. Not 90, but 9D. And they sound the same though, right? And what's T sub n?
T1 plus Tn minus 1. N minus 1.
T1 plus n minus 1 times D. That is the general term of an arithmetic sequence. So the formula is given by T1, take the first term, whatever it is, and add n minus 1 differences, right? Questions? Comments? Observations? General life lessons learned to this point? Nothing? No. For the arithmetic sequence, negative 20, negative 13, negative 6, negative 1, determine T35. Okay, well, before we can find T35, what do we have to know? Well, we know the formula, right? So we have a formula. Here it is. Here is the formula. We want to find T35, means we're going to make N35, right? So what do we need? What's this? T1. Okay, what's T1? Okay, so T1 is equal to negative 20. What else do we need to know? Do we need N? No, we know N, right? Because we want N to be 35. So what do we need to know? D. How are we going to get D? So D is equal to negative 13 minus negative 20, which is 7. Okay, we know T1, we know D. Now we can find T35, right? Okay, so what do? Write down the formula. What's the secret to math? Formula, substitution, answer. So formula, T sub n is T1 plus n minus 1 times D. Let's go up here. We'll write in up here that n is 35. Right? So for this particular problem, n is 35. We want the 35th term. D, which we had to calculate, was 7. Okay? at t sub n. And you don't always have to show a calculation of that. You can look at it and just say it's 7. Right? Negative 20 plus 7 is plus 7 plus 7. So I'll allow you to figure that out yourself without actually showing a calculation. But you should at least state it, right? So we need to state what t1 is. We need to state what n is. And we need to state what d is. Because the formula involves how many quantities? Well, there's t sub n. There's t1. There's n. You can't see this, but I'm holding up fingers each time. I now have 3 fingers held up. And there's d. So there are 4 quantities in the formula. In order to solve a formula with 4 quantities, how many do we need to know? 3. If we know 3, we can solve for the 4th. And that's exactly what we're doing, right? So T35. So now substitution, right? In the grand scheme. Negative 20 plus 35 minus 1 times 7. So order of operations, what do we do? Do the brackets. So we get negative 20 plus 34 times 7. Okay, then what?
Negative 20 plus 238.
Plus 238?
Yeah.
So T35 is? 218, right? Because to do that recursively, we would have had to work our way through every single term until we got to the 35th term, right? So we don't want to have to do that. That's why we have the formula. Determine a simplified expression, okay, for t sub n. So t sub n is t1 plus n minus 1 times d. So t sub n, well, we know t1 is negative 20. We won't know what n is, right? But we do know what d is. So in this case, we're just filling in t1, the first term, and d, the common difference, because what we want is a simplified form. Something that's a little bit easier to work out than this. And when I say this, I mean this stuff here. It's a little harder. Right? There's no glowing yellow dot and blue. Right. Okay, so all we're going to do is simplify. So it's negative 20 plus 7n minus 7, which is equal to 7n minus 27, right? So try that out. Put a 35 in. What's 7 times 35 minus 27? 7 times 35 is what? 210 and 35 is 245 minus 27 is 218. Okay. Works. Nice. Determine n if t sub n is 631. All right, again, so let's list what we know. We know that t sub n is 631. We know that n is questionable. Well, it's not questionable. It's what we want to find, right? Don't know n, want to find it. We know that d is 7. We know that t1 is negative 20. We've listed all 4 of the quantities, right? 3 of which we know, so we can solve for the 4th. Okay, so formula, t sub n is equal to t1 plus n minus 1 times d. Substitution, t sub n is 631. t1 is negative 20. N is, we don't know, so we're going to leave that as n. And d is 7. How are we going to solve this? What's the first thing you want to do? What's the first thing you have to do? Must do. Do what? Okay, fine. What's the first step in solving this? What are you going to do? You got a number of choices. What are you going to do to solve this equation? Yes. Okay, how? What specifically are you going to do?
Multiply the 7 with
No.
minus what?
What specifically are you going to do as a first step?
Expand the 7.
No.
Add 20.
Add 20 to both sides. Why? Why expand something you don't need to, right? Like watch the next step in the solution. So if we add 20 to both sides, what do we get? 651 is, and let's just rewrite that minorly, 7 times n minus 1. What's the next step? Divide by 7. This way we don't have to go and expand that, right? Like, why go 7n minus 7 and then have to collect two numbers, a negative 20 and 7, and then add those to both sides, right? So it's easier if you do it in this order, right? Add the number to both sides, okay? Then divide by the thing you're multiplying by. So what's 651 divided by 7? 93 is equal to n minus 1, so what's n? 94. Okay, add 1 to both sides. That's the easiest way to do it. I don't care. If you want to expand it out, be my guest. It just takes longer and it's a little more complicated. And then one thing to watch out for, which is when you're solving something like this, the tendency is to really want to subtract 1 from the 93 and get a 92, right? So subtract 1, but you're adding 1, right? So just remember, follow along. Okay, questions? Seeing none? Determine a simplified expression for the general term of the sequence shown in the graph. This is the graph. And determine t sub 30. Okay, so what's this axis? Really? Why don't you look at yours? N. And what's this axis? T sub n. So what's T1? 10, right? When n is 1, t sub 1, which, right, tn, t1 is 10. Now, could I ask you what d is? Well, I could. I just did. What's d? 3. So the next term is 13.
It's negative 3.
Oh, so it must be negative 3 because the next term is not 13. What is it? 7. How do you go from 10 to 7? Right, well, 10 to 7 you should be getting out. Okay, so if we write negative 3, is everybody okay with that? Right, because here's what else you could do, right? You could say T2 is, what's T2? What's T3? What's T4? What's T5?
Negative 2.
Negative 2. Sorry. Negative 2. Man. Okay, so you could do that, right? And then from that, you should be able to get the d is equal to, so if you want to calculate it, d is 7 minus 10, which is negative 3. Okay, what else? N is 30. And T30 is what we want to find. Okay, so we know T1, right? What do we need for the formula? Let's just extend, extend the page. Okay, we need T1, we need D, and T sub n. In this case, T sub n is going to be T30. So, formula. T sub n is T1 plus n minus 1 times D. T30, my unknown, is T1. What's T1? 10. What's n? What's D? Really? Negative 3. Okay, solve. This is a solve, right? Not a simplify, right? Because we're actually getting a value. Simplify is come up with another expression that isn't in factored form. Solve is work it out. Showing as many steps as you like. Okay, did you get that? Yes, no, maybe I made a mistake, maybe I did it on purpose, maybe I didn't. Agree, disagree? Little feedback here. This is not a video you're watching of me sitting at home. You're in the room. You can say yes, no. Yes? Okay, majority agrees? Right, because the majority is always right. Well, in an election or something they are, right, because there's no other choice. Okay, questions? All right, so what happened here, right? We had a graph. The points on the graph were values of n and then t sub n, right? So t1, t2, t3, etc. From that graph, we could get t1. We could calculate d. We know we needed to find the 30th term. And so that gave us n was 30. And all right, so now we're just going to do a bunch more examples. Apparently we've done 2 because this is example 3. So if 4 minus 2x, 3 minus x, and 8 plus 3x are the first 3 terms of an arithmetic sequence, then determine the value of x and the value of the first 3 terms. Okay, so how are we going to do that? What do we know? Okay, what do we know? What's T1? What's T2?
3 minus x.
What's T3?
8 plus 3x.
Okay, that's enough hints. Now you tell me what to do.
Subtract T1 from T2. T2 from T1.
You had it right the first time. Subtract T1 from T2. What is that going to give us?
The difference.
Mm-hmm. So let's communicate that. Let's say D is equal to T2 minus T1. So what's that going to be?
3 minus
Okay, and we're just going to bracket everything, right? Especially since we are subtracting a set of brackets. So if we bracket everything as a first step, then when we go through, now we're going to remove the bracket. So what's this become? Which ultimately becomes,
Where did you get the 4x from?
I don't know, made stuff up. No x there. See? Sometimes I'll do it on purpose. That wasn't an on purpose, right? That was messed up. Okay, so what's we're go to?
Minus 1 plus x. Or
And if we're
X
going to say
minus
minus 1 plus x, what are we going to say?
x.
X minus 1. All right, there, we're done. We know what D is, right? Oh, no, but we're supposed to find x. Okay, what's x? Don't say D plus 1, that's right. Although it is, but. Okay, what else is D equal to? What else is D equal to? T3 minus T2. Look, see, I'm just giving you how to solve this now. What's T3? What's T2? Remove the brackets. Trying not to add x's where there aren't any. Well, though we are adding that x. But. All right, what do we get? Okay, now what?
X minus 1 equals 4x plus 5.
Yeah. So what we have is we actually have a system of equations, right? We have 2 equations and 2 unknowns. We don't know D, we don't know x. But we have 2 equations, and that's how many equations you need if you have 2 unknowns. We're going to solve by the method of comparison. Right? Or substitution. In essence, it's really substitution. But you can say, if D is equal to this, and D is equal to that, what do we know about this and that?
They're both equal.
They're equal to each other. So now we go up here and we say, well, x minus 1 is equal to 4x plus 5, which means 3x is equal to, and x is equal to,
-2.
and then D is equal to, you know, or you could go 4 times -2 plus 5, which is -3. Okay, so we know x and D, right? Because we need D. Well, we don't really need D, I guess, do we? We don't need D. But we could just get by with x. You know, optional. Optional. Okay, so what's T1? Well, it's 4 minus 2x, which is 4 minus 2 times -2, which is 4 plus 4, or 8. Yes?
Would it be positive 6 because you
Other
add
mistake?
1 by on each side?
No, you're going to subtract 5 from both sides. I'm going with -6.
now confused.
This goes over here, right? You subtract it. This goes over here, and you subtract it. Okay? And then you just reverse the order you write them in. Instead of writing -6 equals 3x, you just write 3x as -6.
So can you explain to me the optional part that you're...
Well, you don't need d. If you have x, you can get all three terms.
Okay.
But if you have d, you can get all three terms by then going, but I suppose we should do it this way, right? Because we want to make sure, so 3 minus -2, which is 5, and t3, so actually it's not even needed, right? t3 is 8 plus 3 times -2, which is 2. And so my sequence is 8, 5, 2. Is that arithmetic? Yeah. What's the common difference? -3. Question?
If you're using d in the equation, why are you using sorry, if d is equal to -3, why are you using 2 in the equation?
I'm using x, not d.
So you're just substituting the value of x into the equation that's 4 minus 2x. Is that what you're
Into all three of them. Then the verification that x is correct will be that these three numbers form an arithmetic sequence. And I could calculate the d, so then I can see, oh, not only do they form the arithmetic sequence, but they form the sequence I thought they should form. Right? As opposed to working out t1 and then just using d. So really, we could have worked out the 8, and knowing d was -3, just going 8, 5, 2. But I think it's a little better to do it this way with the x, and then you can just verify, right? You get to cross-verify that, hey, this is really true. Right? The d is -3. So, yeah, it all works out nice. Other questions? Determine how many terms. What's determine mean? Show your work, okay? So, what do you know? There's 4 quantities. What do you know? T1. What's T1? T1 is 182. Okay? What else do we know? What's D?
4.
So if it's 4, then we go from 182 to 186.
-1.
Right. So look, if you're just going to figure out the value of D, which is fine, just check that you got it right. Okay? Because if you get it wrong, everything goes bad from that point on, right? I mean, nothing could work. Okay? What else do we know? What's N? Don't know. So we got to find out. What's T sub N? It's on the board. T sub N is written on the board. I just need to write it next to that equal sign. But it's a quantity that exists on the board, on your sheet of paper. It's sitting there. Come on, somebody's got to figure this out. I'm not giving it to you. It is written on the line that says example 4 : determine, blah. T sub N is there. What is it? Sorry? What?
182.
No, that's T1. Oh. What's T sub N? What's the nth term?
T1 plus and then
Yeah, it's a formula. It's not written on the board. What's the nth term in that sequence?
we don't know.
-14. Gold star. I don't have any gold stars, but
Silver star.
okay. How many terms are there? Let's say there's 50 terms there. Which one is the 50th term? The -14. And we don't know how many terms there are, but we know there are n terms. There is some number of terms, the last of which is -14, and I want to know what term that is, right? Like here. What's n? N is 1. What's n here? 2. What's n here? What's n here?
Some numbers.
N minus 1. What's n here? N. That's the nth term, right? We just don't know what n is, but we're going to figure it out. Okay? Does that make sense? Because you're going to do this a bunch, right? So when you're given a sequence where you don't know how many terms there are, we say the nth term is the last term. Right? Because that's how many terms. There are n terms up here. Just don't know what n is. All right, now we get to do the formula. Okay, what's t sub n? Thank you. This took way too long. What's t1?
182.
What's n?
Negative 14.
Nope. What's n?
We don't know.
1.
N. What's d?
Negative 4.
Right. N is n. Right? Don't know n, so it's just n. I mean, I could write n equals n, but I put n equals question mark. N is the thing we want to find. Yes?
So when figuring out arithmetic sequences, the formula is going to be the same for all of them?
No, it changes based upon the context. Sorry. Of course it's the same for all of them. What use would a formula be if it changed based on the context? Oh, the area of a triangle is 1/2 base height, unless it's upside down. No, sorry. But no, math formulas are that for a reason. Okay? If it is an arithmetic sequence, this is the formula. There are none else. Okay? There are no variations of it. It is, it has to be. The area of a circle is pi r squared. It doesn't change based upon the context of the question, right? I mean, otherwise it's not a formula then. It's some expression.
Go to another dimension.
Okay? Yeah.
Where triangles are not 1/2.
It is bio. Like, how much snot can you hold?
Apparently a lot.
Like, really? You ever drink a lot of water and you pee for like 2 minutes, and then you stand up and 5 minutes later you have to go back and pee again? Like, didn't you just empty it? What's the refill time on a bladder? Oh, and this is all going up on YouTube. All right, what's the first step?
It's going to become a viral video.
Yeah.
Subtract 1.
It'll say, go to 2720 and listen to it.
Subtract 182 from
Subtract 182 from both sides, right? Because what we don't want to do is expand this and collect terms and all that, right? Just subtract 182. So that gives me what? Negative 196 is equal to n minus 1 times negative 4. What's the next step?
divide negative 4 by both sides.
Yeah, divide both sides by negative 4. That gives me what? 49. Good man. Did that without a calculator, didn't you?
No.
Really? Used a calculator?
Oscillator.
What's 200 divided by 4? 50. What's 4 less than 200 divided by 4? 1 less than 50? Seriously, you need a calculator to do that? You're going to be able to do some math in your head, seriously. Which brings up an interesting point. Well, maybe not too interesting, but it brings up a point, which is n is always going to belong to what set of numbers?
Positive integers.
Z plus, positive integers, right? So the nice thing about n is you're not going to get a decimal. The negative 4 has to divide in the negative 196. We can't get a decimal. It has to be a positive integer. Z plus, as we say. N, as the rest of the world says. So, no, yeah, N, not W. We say N for W, right? We'll stick with Z plus. Determine how many multiples of 6 are between 20 and 400. Is 20 a multiple of 6?
No.
24 is. Give the man a prize. What's the next multiple of 6? 36. Luckily, nobody knows who said that, right? It's like
Except for all of you two.
30, then what? 36. And where do we end? What is the multiple of 6 that is close to 400 but not above? Or how many times is 6 going to 400? Use your calculator. What's 400 divided by 6?
66 plus 6 through heating
66.6 repeating. What's 66 times 6? Because we don't need the 0.6. 396. That would be the highest multiple of 6, right? Yes? Everybody agree? How is this question like the other one? It's exactly the same. Right?
Like all other questions.
This question is identical to the one above. At this point, the question is identical to the one above with slightly different numbers. So, solve it. I will pause the video. And so, as if by magic. So, here's just, that's why I could just post these answers, right? But then for Kyle and Trevin, that would save them an hour, well, half hour. There are 63 multiples of 6 between 20 and 400. So always a good idea to, in that particular, if you're being asked a question, it's a good idea to actually answer the question. So in this case, we're being asked, determine how many multiples, so we should end with a statement saying there are this many multiples. Right? It's also a good idea to include units on things that have units, although these don't, they're just numbers. The terms between two non-consecutive terms, what's non-consecutive?
They're not.
They're non-consecutive. Yeah, they're not beside each other, right? They're not one after the other. Seriously, find out somebody's capacity.
Someday there's going to be a person on YouTube asking where's the elephant.
Yeah, exactly. Were you at the zoo?
In the room.
This is the elephant in the room. The terms between non-two consecutive terms are called arithmetic means. Determine the 4 arithmetic means. So this is what it means.
Gasp.
Okay, so it means we have a sequence that starts at -25. Then there are 4 other numbers which form an arithmetic sequence, and it ends in 70. Okay, and we have to figure out what numbers go in those blanks such that we get an arithmetic sequence. Okay, so what do we know? Looking at this, what do we know? T1. What's T1? Okay, what else do we know? What's Tn? 70. You guys are good. What else do we know? No, we know one other thing. How many terms are there in total?
6.
So what's n? Okay, that really makes T sub n or T makes it T6, right? We know T6. What don't we know? D. But what do we know? Enough to solve for D. Okay, so T6, 70, is equal to -25 plus 6 minus 1 times D. First step in solving.
Brackets.
Okay, what are the first 2 steps? Which we're going to do in one line.
Do 25.
Yeah, so add 25 to both sides and at the same time simplify the bracket. 6 minus 1 is 5, right? You can do both at the same time. What's the next step? Do we need a calculator to do this?
Yes.
What's 100 divided by 5?
No idea.
Yeah, apparently not.
We're so bad at this.
Yeah. Well, that's not all you're bad at, so. Okay, so I could fill in simply by adding 19 each time in my head without the use of a calculator. Ooh. It's like adding 20 and then subtracting 1. Okay, so there we go. So there we have an arithmetic sequence. -25, -6, 13, 32, 51, and 70. And what they wanted was the 4 arithmetic means, so there they are. Any questions? Yes? No? Yes?
Why is T6 also Tn?
Well, Tn is really T6, because there's only 6 terms in the sequence. Right? Because we know the start and the end, but we want to put 4 in the middle, so we have 1, 2, 3, 4, 5, 6. So instead of calling it Tn, we'll call it T6. Oh my god, 3 more. If the first term and 7th term of an arithmetic sequence are respectively 12 and negative 30, then determine the 26th term. Okay. You see any parallels to what we just did? What's T1? What else do we know? We know T1, we know T7, right? So using those two facts, we're going to calculate D. Once we have D and T1, we can then calculate any term we want, which in this case is the 26th term. Okay? So here, we're going to say for this, n is 7, and we don't know what D is, but it is the same for the entire sequence. So Tn is T1 plus n minus 1 times D. We're doing T7, so negative 30 is 12 plus T7, so n is 7 minus 1 times D. Negative 42 is 6D, and so D is negative 7. Right? I'm just going through quick now. Okay, so now we go back to Tn is T1 plus, etc. And I want T26, which will be T1, which is 12, and n is 26, and D is negative 7. So it's 25 times negative 7. Negative 175. Good, you're getting better. So negative 163. Okay, questions? Seeing none, let's move on.
No.
What? How much time do we have to waste?
Apparently 37.
Go home, watch the video. We're already 37 minutes in. In an arithmetic sequence, T12 is 30 and T13 is 25. Determine the simplified form of the general term. Okay, you're given T12, T13, so you immediately know that. And you get D is 5. Okay, so T12 is 30. T13 is 25. And D is equal to? It's actually negative 5, right? You're going down. So you are subtracting an amount, not adding. All right, and what are we supposed to figure out? Oh, the general term. What do we need to get the general term?
T1.
T1.
Yeah.
What do we know? Well, we know T12 or T13. Can we use one of those? So if I write down T sub n is equal to T1 plus n minus 1 times D, what may I then choose to fill in there?
One,
30.
30 equals T1 plus 5 minus 12 minus 1. 5.
That's what you meant to say, right? That's what I was saying. Process. And then you can always back check that by throwing in a 12 for n and seeing if 90 minus 60 is 30, which it is, or a 13 for n and seeing if 90 minus 65 is 25, which it is. Any questions? whilst you copy. All right, so we know T13, we know T18, right? We have expressions for both, and then what? Millie, your hand to ask a question. Huh? Never mind. Well, I could say that T1 is 54 minus 12D. And over here I could say that T1 is 14 minus 17D. And now what can I say? That 54 minus 12D must be equal to what? 14 minus 17D. So 5D is negative 40, and D is negative 8. Or were we there like 5 minutes ago?
Are we just trying to solve for D the entire time right now?
Nope. Trying to determine the first two terms of the sequence, but to do that I need to get D, and then I need to get T1. So now let's get T1. So T1 is, let's go 14 minus 17, D. So T1 is 14 minus 17 times negative 8, which is 14 plus, what are we at, 80 and 56, 126. So 140. And so, the first two terms, $140 and then, come on, people are watching and waiting.
132.
Thank you. This explains why you did well yesterday. You actually can do math. The rest of them. Okay, so questions? Yes, lots of them. They're on the assignment. Do them now. Homework. You got 20, whatever. You got half an hour. And then all as much time as you'd like the rest of today and tonight and all day Friday and all day Saturday and all day Sunday. Right? And then we'll be back here on Monday.
Oh no.